Here we are given a base net with A being the common cause, so the network looks like A, B, and C. So this is the network, and we are given the conditional probability table, and we're asked to infer about another conditional probability that's not given in the table. So to start, we write this probability C given B. So when it's equal to 1, I'll just write C. When C is equal to 0, I'll write something like not C. And so using definition of conditional probabilities, we can write this as CB divided by probability of B. And this will be the marginal distribution of ABC at the same time. So this is CBA and plus CB not A, CB and not A. Divided by, on the bottom we could do the same thing. This is just a marginal distribution of B and A at the same time, which is B given A, B and A, and B and not A. So then we can convert these these joint probabilities as a function of these conditional ones that are given in the table. So let's try to write that down. So this is probability of A, because there is this term here, multiplied by probability of BC given A. We can further decompose it as B given A and C given AB. This is basically applying the conditional probability formula twice on this joint probability. And C given AB, B and C are conditionally independent, so I don't actually need this. I can just write C given A. And the other term is similar, probability of A, probability of B given not A should be not A. So probability of not A, B given not A, and C given not A divided by this thing, B and A, is just probability of A, probability of B given A, plus probability of not A, probability of B given not A. Okay, let's check how many of these we have. So A is just this, 0.4, and not A is 0.6. So this is 0.4, this is 0.6. And next, B given A is directly this, so it's 0.9, 0.9. B given not A is not the same as 1 minus this. 1 minus this is B is 0, not B given A. Let me actually write it down. Probability of not B given A is 0.1, which in the original notation is B is 0 given A is 1 is 0.1. So this and this, they are not the same thing. So here, this one is B given not A, so it's B is 1, A is 0, so this one is 0.8. And what about this? This is 0.9 again, this is 0.8 again. So the last one is C given A. We know this is 0.5. C given not A, we know this is 0.2. So we know all the numbers and we can just compute the probability.